explaining how it works. So today's video is going to be extremely informative, and I hope you enjoy it and watch it until the end. The dustbin you saw from the intro, this is the dustbin I made using an Arduino, sensors, and a servo motor. Okay, so let's dissect this. Let's see the main way how I made it. So first we're gonna cover the lid. This is the lid. I made this by cutting out a circle from a cardboard piece and then separating it into two different halves. Not exactly halves, this is bigger than this half. I cut it and then I used tape and it sort of made this lid, right? After that, through this part of the lid, I made a hole. Okay, so you can see there's a hole here, and through the hole, I put this thread. This is fishing thread, as you can see. It's fishing thread and it goes through the hole. Now on the other side of the hole, what do we have here? I have a Lego piece. This Lego piece, I've made a knot inside the Lego piece. If the camera focuses, there's a knot inside the Lego piece, and it's taped for extra security. It's taped here, as you can see. There's some tape here. I've used it to stick it onto it so it doesn't fall off. Right, so what's going on here? So here the thread goes up, and I use this for increasing the tension. So this is just a metal bracket and I've glued it here, and this just increases the tension and increases the height, because when there's a higher height, you need less force to pull it, so less torque is required, which makes it easier to lift it up. That's the thing. Here I have the servo motor, and I have added an attachment to the blade. This makes it again a bit taller, and it can just move the lid. Here is the ultrasonic sound sensor. This I will cover, and I'll teach you guys how I wired this up. I'll teach you guys how this works. So everything will be covered, and so this is the main sensing element of it. So if I put my hand in front of it, it senses that there's an object in front. It sends a signal to the Arduino, and the Arduino sends a signal to the servo motor to move. So yeah, this is the main mechanism. And all the power from here is coming from a USB cable, which I made a hole through this dustbin. So this USB cable can be plugged into an adapter or your laptop USB port anywhere, and it will power the Arduino. Or instead of this, you could use a 9-volt battery, but be aware that the battery will be drained out pretty quickly. So that's why I recommend using the USB cable, and you can just directly plug that into the wall using an adapter. Hello everyone, welcome to this segment, and in this segment we'll look at the code for the project and I will explain line by line what each code means. So we begin with this line: include server.h. This is the library for using the servo functions. So we'll use many functions in here that relate to the servo. For example, I'll just pick a quick example. For example, server.attach. So for using this, we need to link the library, which is already coded for us by Arduino themselves. So we include this by saying #include server.h. So we are attaching the library to our program. Okay. Next, servo, my servo. Servo is again another function which is coded in this library. What is this doing? It's basically creating a servo, and the name of the servo is my servo. It could be anything, but I named it my servo. So we're creating a servo. Okay, next. Integer trigger pin is equal to 3, integer echo pin equals 4, integer servo pin equals 9. So these are the digital pins where I have connected each part. So the trigger pin, echo pin, and servo pin. So the trigger pin is 3, echo pin is 4, and servo pin is pin 9 on the Arduino. Next, I have another variable, duration and distance. I have not assigned them a value, I will do that later, but I have just created the variables. Okay, then the next part, long average 3. This is creating an array. An array is a variable which stores more than one value. Here it's going to store 3 values, and I am using it to find the exact distance, so the exact average. This will increase the accuracy of our sensor. Next, I'm creating a float called speed of sound, which stores the value of the speed of sound. This is 0.0334 centimeters per microseconds. Okay, next, void setup, serial.begin 9600. Okay, void setup means what the Arduino will do right in the beginning. So when we turn it on, this is the thing it will do, our device will do. Our Dustbin will create serial.begin 9600. This is for the communication between this program and the Arduino. So we connect it by the USB cable, right? So this will address the relation between it. So serial.begin 9600. So this code can be sent to the device, so we need this code for that. Then next is my servo.attach servo pin. So in this one we are attaching it, our servo, we're attaching it to pin number 9, which is servo pin. I've just wrote servo pin. Okay, next line says pin mode trigger pin output. So as I explained earlier in the segment, bonus segment, is that the trigger pin is the output pin because it's responsible for the TX. The TX is the one that sends the sound waves from the sensor. So it's sending it, so it's an output. So we are just defining it as an output. So the trigger pin is the output. Next, pin mode echo pin input. We know the echo pin is responsible for the RX part, which receives the sound waves. It's receiving it, so we call it the input. So we are just addressing it as an input. Next part, we're doing my servo.write 0. This is turning the servo to the original position. I do this so if the dustbin was already open, it will make sure it closes. So that's why servo.write, my servo.write 0. Delay 100, so it's going to delay 100 milliseconds. Then it's gonna do my servo.detach. So it's gonna stop using the servo. Now we don't need it in this function. We do not need the servo anymore, so it's important to do my servo.detach, this function. Okay, next, void measure. This is another function I created, void measure. And what is happening here? So the first thing is digital write trigger pin low. So this is again, if the trigger pin or the TX was on, we're going to turn it off. Then we're gonna wait 5 microseconds, and then we're gonna set trigger pin to high. Now we're gonna turn it on. So now the trigger pin is on, so delay microsecond 15. Now we're gonna wait 15 microseconds. We're waiting 15 microseconds, and then we're gonna turn it off. Digital write trigger pin low. We're gonna turn it off. Next, duration equals pulse in echo pin high. So this what this means is it's gonna set the duration, the variable we made in the beginning called duration. We're gonna set that value into pulse in. This is another function. Pulse in is the time it took for the echo pin to receive it. This is what this function means. Why did we put high echo pin? Because this function has two entries, echo pin and when it was on. Then we will receive the value for duration. So the duration will be equal to how long it took for the echo pin to receive the sound waves. Next, distance is equal to duration divided by 2 multiplied by the speed of sound. This is the formula, speed distance time formula. Distance is equal to time divided by 2 multiplied by speed of sound. So we know the formula for calculating distance is equal to velocity multiplied by time. So here that's what we're doing. We're taking the velocity of sound and we're multiplying it by the time it took divided by 2. Why are we dividing it by 2? Because the waves have to travel 2 times before it gets received. Because it's gonna echo, right? So it's gonna travel one way towards the object and then back. So we want one way, the distance one way, not how much it traveled. So we're gonna divide it by 2. Okay, next this is another function, void loop. This is what happens again and again and again. It keeps on happening. This is a loop function. So for integer I equals 0, I is less than equal to 2, I plus plus. So what does this first mean? So this is how for loops actually work in C++. Now it starts with making an integer called I, okay? And we're gonna set this integer to I as 0. So every time this for loop is run, I is gonna be set to 0. Okay. Then at the end of the loop, always we're gonna add 1 to I. So I equals 0 is gonna do the loop and then it's gonna add 1 to I. So I is 0, I is 1, I is 2, I is 3, I is 4 after it finishes. Now the middle value is the condition I is less than equal to 2. So it will not exit from the loop until I is not less than or equal to 2. So if I is 1, it will keep on running. If I is 2, it will keep on running. But when I becomes 3, it will exit the loop and go to this way. So what are we doing in this loop? We are measuring. So we're gonna perform this function. This whole function we're gonna perform it. Okay, then we're gonna set average, the integer we created, array we created, to set it as the distance. So whatever is the average of I, that's going to be set as the distance, and then delay 10 milliseconds. Sorry. It's going to keep on running this 3 times, so it's going to collect 3 values. So the first value will be this, whatever the distance comes, the second value is whatever it is, the third value is whatever it is, and then distance is equal to the average of 0 plus average of 1 plus average of the second. So the 0th, 1 and 2, and we're gonna find the average by dividing it by 3. That's all. Okay, next is if the distance is less than 20. So if the distance is less than 20, it will follow this, whatever this is. If it's not, then it's not going to care about this. So if the distance is less than 20, we got going to be my servo dot attach servo pin. So we're going to activate our servo. I'm going to wait 1 millisecond and my servo dot write 0. So it's going to open. It's going to wait 3 seconds. Then it's going to do my servo dot write 150. 150 is the one I found which closed it. And delay 1000, then my servo dot detach. So what is this doing? It's going to make it active. Wait 1 millisecond. It's going to do my servo dot write 0. So it's going to open it. Open. It's going to wait 3 seconds because the person needs time. Whoever's dropping the trash needs a bit of time. So we're going to wait 3 seconds. Then we're going to do my servo dot write 150. That takes it to the other side. And when it goes to the other side, it closes. Then my servo dot detach. That's going to make our servo inactive and just close it. And that's all for the coding part. So that's all. And now next I will show you the wiring schematic. Hello everyone, welcome to this segment. Here I'm going to show you guys the wiring schematic. This is using an online simulation called WalkWe. You can see here WalkWe. So I've made this simulation myself. I've uploaded my own code to this. You can see here. This is the same code that I have written, and I've also placed and wired everything up, and it'll be better and easier to show you guys what's happening. So here's my Arduino, the main thing. To this I've connected 5V and ground. So the 5V pin connects to the positive rail of this breadboard, and the ground connects to the negative rail of the breadboard. I added a breadboard because it makes connectivity much more easier, or then you have to solder things and it gets a bit hard. So here I've just added it to positive rail, negative rail. Here is my ultrasonic sound sensor, and I've connected the VCC to 5V and ground to ground, negative rail. This is a positive rail. And then for the trigger pin is going all the way to pin number 3 of the Arduino, like this. The echo pin goes up here and then connects to pin number 4, and that's all for the ultrasonic sound sensor. Here I have my servo motor. The brown wire means the negative ground, so I connect this to ground rail, negative rail. The red wire means it's the VCC, so I connect the VCC to the positive rail. And then I have the signal, PWM signal, that connects to pin number 9. That's connected to pin number 9. So that's all the wiring